Hello, everybody. This is Michael. In this video, we will discuss about the sub-module analyze for Sobel real-time edge detection system. Okay, so from previous video, we get the system structure like this. So this is sensor, camera sensors, and this is sensor control signal. This is the data signal, and this is LCD, and this is HDMI signal, and this is HDMI controller read information interface, I2C interface. This is HDMI data display interface. Okay, differential pad. So this is the FPGA. So we already get the system, but structure. We already get the system structure, but inside the FPGA, what's the modules situation? What's the modules structure, layout, and so now let's analyze the things, the coding structure inside FPGA. Okay, so let's take a look here. So this is the big picture about the FPGA coding module. Okay, so the first one will be the camera module. The camera module will take over the sensor handling, the camera sensor handling, and produce the RGB data, and also generate a done signal. When it produces 1 pixel RGB data, and then will generate a done signal, tell the following module, we already have 1 pixel data available. Okay. So the next module will be the Sobel module. The Sobel module take in the pixel data information and do the Sobel algorithm calculation handling, and then we'll output the RGB data for the HDMI module. And when this Sobel module generate one pixel RGB data, and the Sobel, after the Sobel algorithm RGB data, and it also generate one done signal for the HDMI module. The HDMI module take the pixels data and then generate the display signal to the LCD to display, to do the real-time display. Okay, so this is main 3 part of the code inside the FPGA. And let's take one by one what's inside these camera modules first. Okay, so take a look at this picture. So inside this module, we will have 2 sub-modules. The first one will be the camera control module. The camera control module will take over all the control signal and initialize the camera sensors and setting the register by the I2C bus, setting the register of the camera sensors, and for example, setting the resolution, setting the output format as a RGB 565, and also can control the camera sensors reset or power down. Okay, and also will be able to provide the sensors clock, the main clock for the sensors. And the second module in the camera module is the camera data. The camera data is only handled with the data which output from the camera sensors, and also separate the RGB data from 565 to RGB 8B RGB, 8B R, 8BG, and 8B blue. Okay, and then generate output done signal to the Sobel modules. So this is the camera data produce the RGB data for the Sobel for further processing. Okay. Then next step, we take a look at the Sobel modules. So for the Sobel modules, they will have three Sobel modules to handle the algorithms. So first things, as we know, the Sobel kernel, the Sobel module algorithm, the Sobel algorithm is only able to take the grayscale value. So we will have the first module is change the RGB to grayscale. Okay, so produce the grayscale value for the Sobel kernel. For the Sobel kernel, after the algorithm calculation, it produces the grayscale for next module. Then the last module will convert the grayscale value to the RGB and then provide the data for the HDMI module to display. Okay, so the last module will be the HDMI module. So the HDMI module will have a controller inside the HDMI modules. Will be take over the RGB data and produce the signal which the HDMI need to display. Okay, so this is the whole picture of the code for the Sobel real-time edge detection system. Okay, so once we get the whole picture, we will able to coding easily produce the module interface code for the whole system. Okay, for the whole system. So next video we will actually show you how to coding the every interface and to show you how to code it from scratch. Okay, so this is for this video, and I'm Michael. I hope you like it, and subscribe us, support us. Thank you very much.